Welcome. Let's try to solve another Leetcode problem. 1490 clone N-ary tree. So we are given the root of an N-ary tree and we're going to return a deep copy of the tree. So the deep copy is not just the reference. So for example, if we just return the root, it's going to be wrong because this is not a deep copy. So let's just check that. So as we can see from here, it is a sad node with a value 1. So this is a value 1 but was not copied because it is a reference to the original one. So we cannot prepare the reference because we actually need a deep copy. So it's going to be the deep copy of the root. So now as you can see it works. Actually it can pass. But in an interview, this is not allowed. So there's no meaning to just use a library of deep copy to make it work. We have to write a function. So there are basically two ways, DFS or BFS. I think the easiest way is going to be a DFS. So we're going to prepare a node and we're going to copy it one by one. And we're going to use the recursive function to copy it. So now let's just start copying. So if not node, so this means the node is going to be empty. So we just need to return a none. Now we are going to copy it. Let me prepare a current node. So it's going to be a node with the node.value. So this is a copy of the root node. So after that, we're going to copy its children. So this is like a recursive function. First of all, we're going to prepare a copy of root node, and then we're going to copy all the children. If we finish all the copy, we just return the root node, which is going to be the current. Now let's just check the children. So for child in node.children, so the node.children going to be an array. Inside of the array, it's going to be an array of nodes. So for example, 3, 2, and 4. And now we just need to put 3, 2, and 4 inside another array, which is in the current.children. So the current.children is going to be an array. So we just need to append. Now we're going to start copying all of the nodes. So for example, we're going to copy a 3, but while we copy this 3, we're going to also copy the children. So for example, node 3, 5, and 6 together. So we're going to use a DFS to copy all of them. Yeah. So it's going to be a DFS of the child. Yeah. So for the recursive function, normally we will not analyze all the details. So for example, we just analyze 2 layers. It's going to be easy for us to understand. So first of all, we're going to prepare a root node. So this current is going to be a root node. This is a copy of root node. It's going to be this node 1. And then we're going to check all the children. So for child in node.children, it means we're going to first check this node 3. And then we're going to put it inside. So current.children is going to be an array. So we're going to append the DFS this child. So this child is going to be this node 3. And for this node 3, we're going to run the DFS. But just ignore other layers. Just think 3 is a leaf node. So what is it going to be? As 3 is a leaf node. If not node, 3 is a leaf node, it is okay. We will not return none. And then we're going to continue. So this current is going to be the node 3. And there will be no child for this node 3 because currently we will ignore the other layers. We only consider this node 3 as the leaf. So we just return this current. It means we're going to return a node 3, and we're going to return a node 2, and we're going to return a node 4 as well. So after all those returns, it's going to be a node, and we're going to put the node inside the current.children array, and finally we just need to return the current. So this is how to analyze the recursive function. So finally we just need to return DFS root. Now let me just run it and submit it to check if it can pass. As you can see, it passed all testing cases, and it's pretty fast. And the time and space complexity is going to be ON because we are not sure if this is balanced or not. So if it is a linear tree, so of course the space complexity is going to be ON. But no matter what kind of tree, the time complexity is going to always be ON. Thank you for watching. See you next time.